Welcome to this instructional video on changes in matter. So today our objective is to compare and contrast our different types of changes in matter. So that's physical, chemical, and nuclear changes, and be able to identify a type of change based on using our observations. So a big focus in this is kind of what can we look for to actually be able to identify those changes. This is also our first instructional video that I'm looking for you to take notes on. So I want to start by just going over a couple of reminders for what our notes should be looking like here. And because this is also our first set, I'm going to go over a few tips and tricks along the way just to help you with this first set of notes. So the first thing we want to do is divide our note paper up, right, into our different sections according to that video in 1.2. And then add the topic, date, and page number at the top. So our topic for this one is changes in matter notes. That should be your title there. And then for me, my page number that I'm working on is page 3, but maybe you're on page 1, maybe you're on page 2. Should be pretty early in your notebook though. So we've got our title, all of that is ready. The next part is that you're going to write your notes in the main section of the video while you watch. So make sure you pause and rewind as necessary to be able to write notes. So you're going to end up with 3 sections. I normally wouldn't tell you this right away, but for this set of notes, it's nice and short. You're going to have 3 sections, and you can split into 3 if you want to have 3 sections that way. You can use bullet points with your 3 sections and skip a line in between. You can write in paragraphs. It doesn't matter. Whatever works the best for you. Personally, I like to use bullet points. I like to have my topics and then have some indentations underneath, but whatever works for you. Once you've gotten your notes written here and you've already watched the video completely, you can add your keywords, phrases, titles, questions, etc. to that left-hand column, so it's easier to reference what information is on the right side. And then at the end, you're going to write a 2 to 3 sentence summary about the notes, about the differences between those changes in matter. All right, so let's go ahead and dive in. First, definitions, very important. There's 3 categories of changes in matter, and you'll notice we only saw the first 2 in our observations on those first few days of school. So number 1 is a physical change. In a physical change, no new substance is formed. So our example here is chopping wood. We can chop the wood into teeny tiny bits and get little bitty particles of wood, but the wood molecules, the chemical of the wood that makes it up, doesn't change. We still just have tiny little pieces of wood, but it's still just wood. Whereas a chemical change is a new substance being formed. And this next part is important. So it's not just a new substance being formed. This particular new substance is just a combination of existing elements. So for example, here with our chemical change, when we're lighting the wood on fire, the wood is combining with the oxygen in the air to produce water and carbon dioxide. You don't need to know that, but what you need to know is that we had certain chemicals to start with, and then we've formed new chemicals using those same elements. We've kind of gotten them to rearrange by changing the energy. That's what a chemical change is. We get a new substance, but the new substance is just a combination of what we already had. But in order to get them to form a new substance, we had to change the energy and get a chemical reaction. And finally, the ones that we couldn't demo, and you'll figure out why when we get more information on this, are nuclear changes. And in nuclear change, we also have a new substance form, but particularly this is the only way to get a new element, to get a brand new element. If we start with uranium and we want to get krypton, that's a nuclear change. We have a different element. We're not just rearranging our chemicals, new element. So now we have a slide on each one. So for physical changes, they're reversible. They're the only ones that are reversible. So some evidence we can look for. If we're looking at some sort of change in matter, we want to be able to identify it as a physical change. We might look for a change in size, a change in shape or location. So something like tearing or ripping paper or throwing it across the room. Phase changes. So anything like melting or freezing, boiling, condensation, sublimation, or evaporation, these all don't change the chemicals. So if you have liquid water and you put it in an ice cube tray, you pop it in the freezer, you end up with ice, but it's still H2O. We're still talking about water in that case. Dissolving or recrystallizing is another good one. If we have a bunch of salt and we dissolve it into water, we mix it all around, it completely dissolves. We can't see it anymore. but we still just have salt and water. We didn't create any new chemicals. And recrystallizing is the opposite. If we have a big pot of salted boiling water, let's say we're making pasta, and we put it on the stove and we kind of forget about it, so it just boils and boils and boils, eventually we're going to not have any water left because it all boiled away, all evaporated, but the bottom of the pot's going to have those salt crystals again. So it's kind of the backwards process of dissolving is what recrystallizing is. And then separating or mixing. Let's say we have some oil and water, we pour the oil off, we're left with two separate containers. Mixing stuff up, maybe we're making lemonade and we're combining the ingredients to make lemonade, but we don't create any new substances. We still just have all those components, they're just blended really nicely. Substances only change form. They might look different, but we haven't created anything new. So here's an example of dissolving. And then we also have an example, this is dry ice. So dry ice is solid carbon dioxide and it sublimes. So it goes from a solid form to a gas form, but it's still CO2. This one's solid CO2 and the gas is gaseous CO2. But we're still talking about CO2, no new substances. On the other hand, chemical changes are not reversible. Some evidence we might see for a chemical change would be a color change. A change in temperature. We mix two things and all of a sudden it just gets warm without being put on the stove. A texture change. Maybe something started out really shiny and all of a sudden it's really dull and kind of brittle. A new gas forms. We would know a new gas forms because we would either see the smoke. Maybe there's a new smell, something like baking a cake in the oven, you can smell it. That's a really good example of we know that there's some gas forming because we can smell it. Could be fizzing. You put an Alka-Seltzer tablet in a glass of water and all of a sudden it starts bubbling up. That's creating a new gas. That's something new that's forming. Energy change. Energy change, the best example I like is a firework. We can see light produced. We hear the sound. We know that there's motion happening. Another form of motion could be if we add a little drop of solid into a liquid and it starts like skittering around the surface. We can see it move. And then this is a solid form. So it's related to texture change, but specifically what's called a precipitate, which is just a fancy word for a solid that forms, but the solid is in a liquid, so it's kind of hard to see. That's what that would be. And this is where we get new substances from whatever chemicals we already had. So our chemical bonds are broken and new ones form. So here's an example here. We have two clear liquids. When we combine them, we get this yellow precipitate. So we got a color change. We got a solid formation, that precipitate, and we got some color, right? Here's another example. So in this case, we have a copper coil, we added a clear solution, and over time we get these gray crystals and our solution turns blue. A lot going on in there. Finally, our nuclear changes. So nuclear changes are super, super rare compared to the other two. And that's because they require incredible amounts of energy to happen. So some evidence for a nuclear change, the only one we've got is ionizing radiation is released. We're going to learn a heck of a lot more about radiation later on. For now, what we need to know is that the nucleus of an atom actually changes its number of protons. This is kind of the definition of new elements, is when we have a different number of protons. So an example here, this is a zoom in of an atom where we split the atom. This is called fission. This is what happens in like nuclear power plants and stuff and like atomic weapons. And then another example is the opposite. Instead of splitting a big one into two small ones, if we have two small ones fusing into a bigger one, it's called fusion. And that happens all the time. On our big star we call the sun, we're fusing hydrogen atoms into helium, making a bigger atom out of it. So your notes for this video should include the definition of each category, should include whether it's reversible or not, and then as many examples as you can of what evidence you would see, hear, or smell. You could even be more specific about this if you want to talk about some observations from our demonstrations in class. And then of course some examples, whether they were examples in class or some that we have talked about either in person or in this video. Some examples are really helpful to help you kind of grasp all of that.